Okay, hi guys. This is part two of our balancing chemical equations lecture. So let's just get started here with the types of different chemical reactions. That's what we're looking at today. Now, before you see quite a few of them. We're not responsible for all of these. Mostly we're just going to be dealing with the synthesis slash combination reaction. You sometimes hear this called a composition reaction too, from what I understand. I think the EOC is using composition reaction. Okay, so everywhere else I've ever been, it's been the synthesis or combination reaction. But if you see that on the EOC, you know what it means. Okay, it means the same thing: synthesis, combination, composition. Okay, that means that you're building something up. If you're synthesizing, you're building something up. So we use these generic letters here to indicate this building up of these elements. So if you see like element A plus element B, what they're going to do is they're going to combine to make AB. So let's just pretend that this was aluminum and this was chloride. They would come together to make aluminum chloride. Okay, so building up is synthesis. That usually helped me remember it. The second one that we need to look at is a decomposition reaction. That means it's decomposing. Okay, you started with something whole, like AB, and those are your reactants, remember. Here on the left is your reactants. Even though they're together, they're still your reactants, but they're going to decompose into A plus B, meaning these are going to be by themselves. Okay. We also have a third one, which is called the single replacement reaction. And as you may already see the little example here, it just means that one of these is going to be replaced. And we're going to be able to determine which one's being replaced by looking at an activity series a little bit later on. So it takes on the generic formula. If you have A plus BC, like a compound, then what can happen is if A is higher up on the activity series than B, A has the ability to kick B out, and now its new partner is AC, and then B is left alone. Okay? We have the fourth type, which is a double replacement reaction, and its generic formula is AB plus CD. And that, if you notice here, the A, which is the cation in the first reaction here, or the first reactant, I should say, the A will go with this anion, okay? And then these two go together. So A will come together. I think of it as like a double date. You go with one couple and then there's a second couple, but then this end up liking this person better, and then these two like each other better. So they kind of switch partners. Okay, so A is now with D and C is with B. But notice how you still name the cation first. So C goes before B. Okay, so this is the cation named with this anion. We do not have to worry about neutralization reactions at this point. Don't worry about them. If you go on to AP, this will come back. And we do not have to worry about polymerization. Don't worry about that either. But we do have to worry about this one, which is a combustion reaction. This is always with a hydrocarbon. Notice the C and the H, hydrocarbons. And it's being burned in oxygen, okay? And these are pretty, I mean, they're kind of interesting to balance, but we can always recognize the products, which is always going to be carbon dioxide and water. So that makes it easy at least. So when you're burning a hydrocarbon in oxygen, you can always depend on at least these two products, carbon dioxide and water. Okay, so let's look at each one a little bit more in depth. We're just going to start with our first one, which is a synthesis reaction. As I had mentioned earlier, we take two and build them up, synthesize them, and make in one compound. So we have some sodium and some chlorine gas. We put them together and we get sodium chloride. Now don't forget to balance these as we looked at in our last unit. Remember Cl2, that's a diatomic element, so it only comes in 2 atoms of chlorine. And then we had to balance this because we know that this was a 2 chlorine, we had to come over here and make this into a 2, so we got the 2 chlorines. As a result, we gave ourselves 2 sodiums, so to indicate that, we're going to go back here and give ourselves 2 sodiums here. Okay, so once again, the generic general formula is A plus B yields AB. So you get an element or a compound of one, an element or compound of another to become a compound. Okay, and this is just kind of showing this. So now let's look at some synthesis reactions. Doesn't always have to be just two elements like I had just mentioned. You could get these two compounds together. You've probably heard of photosynthesis. If you take some carbon dioxide and some water, you're going to yield afterwards some sugar and some oxygen gas. And you've probably seen this in the morning if you've looked closely to leaves, some little oxygen bubbles forming on the top of the leaf. Okay, that's just an indicator that it produced some excess oxygen that it doesn't need. It's its waste product. Here's an example of water, noticing how two elements are building up to make water. So we take some hydrogen gas and some oxygen gas and we make water. Formation of salt, Na plus Cl yields 2 NaCl. So one more time, your general form is A plus B plus C. Synthesis reactions, the first type. Okay. Again, here's our decomposition reaction. We take one thing and break it down into two separate things. So let's look at water. We would need 2 molecules of water to break down into 2 moles of this hydrogen gas and 1 mole of oxygen gas. And I notice I said the word moles again. We're going to talk about molar ratios more when we get to stoichiometry, but this is what I'm trying to lead you to, so when we get there it'll be a little bit easier. And this also means 2 molecules and 1 molecule. Okay. So once again, you have the general form of AB and then breaking down into A plus B. And here's just a couple examples of some decomposition reactions. If you go on to AP, this is one of their labs. You'll take some hydrogen peroxide and decompose it into water and oxygen gas. It's a pretty fun lab. If you take the electrolysis of water and you apply an electrical circuit, then you could actually break down water into its individual components of hydrogen and oxygen. And you can just take a look at a couple other ones. Notice how you're starting with 1 and you're going into 2. Okay, so that's the general idea behind a decomposition reaction, decomposing. Okay, the next one are single and double replacement reactions. And if you look at the single, notice how just one of them is on its own, and then you have a compound. Now, its general formula here is A plus BC yields AC plus B, but you have to determine if one's going to replace another one by looking at the activity series, which I'll show you here in a minute, okay? So if magnesium is higher up on the activity series than copper, which it is because magnesium is a pretty reactive metal, then it has the ability to kick copper out of its place. Okay, no more copper. Magnesium is now with the sulfate ion and copper is all by himself. Okay, so that's a single replacement reaction. You use the activity series to decide on if predict if these chemical reactions will even occur. Double replacement reactions, we had just said before, AB plus CD yields AD plus CB. So if we have calcium carbonate and hydrochloric acid, we could take this calcium, notice it's here, and pair it with the anion of the second one to get calcium chloride. And then we would name the hydrogen, which is the cation of this one. Okay, that's the C part here. Okay, and then we put that together with the CO3 right here. And hopefully you guys remember this is carbonic acid. Remember we were naming those acids earlier. Okay. So I mentioned the activity series. You're going to need this. I also have it printed on one of the little worksheets that we're going to be working on this week. So you're going to need this here. And remember I had mentioned magnesium is higher up on the activity series than copper. Copper is pretty low down there. Okay, so a lot of things can kick it out. But the biggest loser of all is gold. Anything can replace gold. It's very sad. And silver is pretty low down there on the pedestal too. Okay, so if it's higher up, it has the ability to kick out anything that's below it. Here's the halogen reactivity. Remember group 7s. We know that fluorine is the most reactive, and then it just kind of goes down from there. Okay, let's look and see. Will these even occur? We have iron, we have copper chloride. Well, we want to know if iron can replace this. Well, we already know that it can, because copper, if you see copper, unless it's up against silver, it's a pretty good indicator that you're going to be able to replace it. Okay, so yes, iron is here. So you just look, iron is right here. Copper is down here. Iron has the ability to kick him out and make him on his own. Okay, so now this is going to happen. This will occur, and we're getting iron chloride plus copper on its own. Let's look in zinc. Can zinc replace this hydrogen? Let's go take a look. We have zinc here. We have hydrogen here. Yes. Okay, so now zinc is going to come together with this nitride ion to get zinc nitrate. And then we have hydrogen gas as a result. Remember, these can't just be H by themselves. You have to throw a 2 there. It's diatomic. Magnesium chloride, can that replace bromine? No. Okay. Can bromine replace Cl? Well, let's go look here. Bromine and chlorine. No. So we're not going to have a reaction here. Okay. So once again, general form is A plus BC yields AC plus B. One replaces the other if it's higher up on the activity series. Single replacement reactions. And this is just another slide showing this a little bit more. You can just keep going back to your activity series to find out if magnesium can replace aluminum. If it can, then the reaction will occur. You mix them up, and then this is what you get at the end. Okay? But can aluminum replace magnesium? No, magnesium's higher up, so this does not have the ability to replace this, so therefore no reaction is going to happen. So make sure you check those out when you're going along. One more time, this is just showing a double replacement reaction. This is kind of cool because barium has the uncanny ability to cause precipitates. So as you can see over here, it's starting to have like a little bit of a precipitate happening. But this one is potassium carbonate plus barium chloride. They're going to replace one another. And so now we're going to get this K, remember? So we get A and D together, and then we have barium carbonate, and then we get C and B together. Okay? So as long as you understand the general formula, they're not that hard. And this is just kind of showing you, I guess, just like a visual representation of what's going on here. Barium actually is taking this place. He's taking his place. Okay, so this is just showing this occurrence right here. And that leads us to our last type, which is the burning of hydrocarbons. These are your combustion reactions. And notice how you always have some sort of hydrocarbon burning an oxygen gas, always yielding carbon dioxide and water. You can always count on those, okay? So when I do these, I do them in alphabetical order. I balance the C's first, then the H's, and then the O's, because O's can be a bit of a nightmare. Okay, so C's are easy enough. I see that I have 5 over here, so I can just go and put 5 here right away. And then I had 12 H's originally, so I had 2 here. If I put a 6, that should take care of that. And then I get 6 O's as a result. And then we have these here, which were the 10 O's, so I have 16 O's on this side. So to get 16 oxygens over here, I would take the 8 times a 2. So again, I do it in C, H, O order. My carbons first, and then my hydrogens, and then my oxygens. You don't have to really worry about this one. It's a little bit complex, but this one should be easy enough. Remember, do our C's first. I have 15 of them, so I'm going to put a 15 over here. Okay? And then I had 28 of them, so make sure you have a 28 here. Count up all your oxygens here, and then put it, I guess it's going to be 44, so I need 22 over here. Okay, so these aren't too bad if you just know that with the hydrocarbons you would have to do the C, the H, the O. They're always burning a hydrocarbon and oxygen and always getting carbon dioxide and water as a result. So to wrap this up, there are the 5 different types, which are synthesis, decomposition, single replacement, double replacement, and combustion reactions. So we're going to work a few of these. We're going to do a little bit of a hands-on activity at lab today to see this more. And then we're going to follow that up with a snowman challenge game. So I will see you soon in class.